In this video, we're going to look at Chapter 14 out of the Test-Driven Development by Example book, and the title of the chapter is called Change. It's an interesting title. In this chapter, we are going to be looking at reducing money with a conversion, so currency conversion. So we're going to be looking at that and setting that up. And let's take a look at what that's going to happen. So we are going to create an object called pair, and that's going to represent currency pairs. And we're going to be using this as a key to a map. Since we want to do that, we're going to have to implement a equals and hash code on that, since it is going to be used as a key. And then we want to add a rate. So remember, our bank is going to be determining the conversion rate. So the bank is going to be the holder of truth conversion rates. Now, I want to point out that the examples in the book use hash table, and that's like circa Java 1.2. So things have evolved quite a bit. I'm going to do the implementation using a hash map. Biggest difference between the two is hash table does have thread safety involved. If we needed that, we could use a concurrent hash map. That's kind of more preferred in more modern Java languages. But for what we're doing, we don't need to worry about that. So good old simple hash map is going to be just fine for what we're doing. Now, obviously, we're going to need a method to return a rate for a given to and from, or from and to currency codes. And then, of course, we're going to need to be able to add in a new rate. So that method is going to take in two currency codes and a conversion rate. Now, our interface expression, that reduce method, we're going to modify that to accept a bank object. And that's going to allow expressions to inquire the bank for the appropriate conversion. So, like I said, we want the bank to be the knowledge of the different rate conversions, not the expressions or the implementations of the expressions. So we'll need to change, by changing that method, the hard implementations of money and sum, we're going to need to accept the bank parameter there. And then, of course, the money implementation, we're going to need to change that to actually use the conversion rate in the reduce method. Now I'm going to jump over to IntelliJ and start going through these changes. Okay, I went ahead and did a little bit of coding ahead of time. So on line 71, I've gone in and added in a new test method, and this is to test money or test reduce money using a different currency. So this is going to come in, we're going to add in a new bank rate, and then we are going to test that it's coming through. And I want to point out that we're just using an integer here, so our actual math behind it is not going to be terribly accurate because we're just using ints. So if this is a real program that we're implementing, obviously we'd want to be using something different than integers for more complex operations. And then also what we want to be able to do is, the author called it test identity rate, which I thought was a little strange for it. But what we want to do is when we pass in two rate codes of the same, we want to make sure that we get one back. So we're going to add in these two tests. Now, coming over here to bank, I did modify bank to have a rate property, and we're going to go in and actually implement this. So this is just a kind of faking out what it's going to do. So it's always going to return back 2 or 1, depending on what we've passed in as the parameters. So it will get our test green, but it's not going to do anything. And then finally on money, you can see down here on line 37, effectively did the same thing, same logic. And then this is just setting up that fake logic to get things cooking for our test. But first we got this compiler error. Now, I've set this up, and you can see IntelliJ is giving me a little light bulb there. I can go in there and just say create that method, add rate in bank. So that turns out to be exactly what we want. Give us a little bit better name. From to, and make that rate. So now we have variable names that make sense rather than what was auto-generated. So IntelliJ has some really nice refactoring methods there. So let's come back over here to money test and we'll run this, and that should be running now. You can see that passes, and this guy is actually going to fail for us. Oh, I thought he would fail. Okay, so that test is going to fail in the future. So, yep, always going to return 1 for us. So we will be going back and implementing that. But the primary one we want to be focusing on is this test reduce money, different currency. So the first step we want to do is come into our expression interface. And this, we want to pass in a bank object. Like so. So now this is going to make money, which implements it, unhappy. We can see right here, we are unhappy about that. And click on this. I thought there'd be an option just to refactor, but apparently not, unless I'm not seeing it. So that fixes that. Sum's going to be unhappy as well. And you can see here we didn't use override, so I'm going to go ahead and add that. Just a good habit saying that you do plan that method to override or implement a method from the interface. So without that, I could have extra methods in there and that don't implement the interface. A very easy mistake to make. So let's come back here and run this. So now we can see that this is not working. So we want to say this. Make sure everybody's still happy. And let's come back and run the test one more time. So that is back to being happy. Next, our bank right now, this is pretty dumb. So what we want to do is implement the functionality for the rate. So like we said in the slideshow, we wanted to bring in a new class called pair. So we're making this immutable. Now if I hit Command N inside of IntelliJ, I say generate a new constructor. So we'll require from and to. And then we also need to add in equals and hash code. So let's go ahead and take the default IntelliJ settings. So let's see how we did there. So this is a little more elaborate operation than what was implemented. So if we pass in the same object, it'll return true. If it's equal to null or a different class, we'll return false. And as long as it's the same one, and we are going to test to make sure that the from are equal and the twos are equal. So that should pass that. And double checking that. So everything looks good there to me. So that should do what we want it to. So now let's come back to bank. And say hash map, and that's going to be pair integer for the rate. I'm going to call that rate map. So it's a little bit different than what's the actual implementation from the book. So let's go and complete the add rate. So this will actually be working now. It's going to do something rather than just being a stub of a method. So we can say is rate map add, or put, I'm sorry. And you can see in the book, he actually creates a new integer in this method, and we have auto boxing now inside of Java. So even though we're taking in a primitive, it'll get auto boxed to an integer, so that should be fine for us. So let's make sure that still runs. So that is working for us. Now we want to be able to actually get the rate. Now what we want to say is now this is going to go away, and we want to say return rate, like so. And we're going to be adding a little more code there, because what we need to do is make sure if we have from and to are equal, then we want to return 1. But we'll implement that in just a couple of minutes. First, let's make sure our tests are still working. So that is good. Now, I think we should have broken this one. Yes. So now we want to come back over here. We can get rid of this commented out code. So now you can see that I've changed this. So we're now getting that rate, and this should fix this test. Oh, what did I do there? Yeah, a couple typos. So get those fixed up. You can see the test run. And then finally, what we need to do is down here, what we want to do is get rid of this, like so. I'm going to say bank rate. So we're going to say this currency 2. So we're taking in the object of the money. So we're getting rid of the fake implementation and adding in the real one. So now when we reduce money, we want to make sure that we are passing in the right currency code of what it is and then what we're going to. And then we're going to pass in the target type. So let's go ahead and come back over here. Run that. You can see that is passing. Now let's come up to the top of our class and run this. Make sure all our tests are passing. So everything is still in the green. So we did a lot of refactoring there. So let's go through. We can see that we added in on line 71 a new test method for different currencies. And then we also add in, make sure that the same rates return an accurate value. Take a look at the bank class. That was probably the most refactorings that we had. So we added in a new hash map. And that was going to take in a new class called pair. And that pair is going to be basically a pair of values of from and to rates. So we added that in. And now we added in methods that are going to allow us to add a rate and then query a rate from our bank object. And you can see on line 17 there, we added in additional logic. So if the two rate codes are equal, we always return 1. And then here's our pair implementation. we just have two properties there. I did declare them private final and declare them in the constructor, so these values cannot change on us, making this immutable. And then also threw in, used IntelliJ to generate the equals and hash code methods. Some had very minor changes because we changed the expression interface to accept bank on the interface. We had to change our reduce method to take bank as well, even though we are not explicitly using bank at this point. So I'm going to jump back over to our to-do list and can see that I've crossed off money with conversion. Now I'm also crossing off 5 plus 5 equal 10 because we did complete that logic. The author checks that off in this chapter, so that is now crossed off the to-do list. He didn't explicitly call it out, not that I saw at least, but we do have test coverage for that logic. In the next video, we are going to go look at the $5 plus 5 francs equals $10. So we are going to be setting that up and make sure that is working as well.